right, so we are just going to take some quick notes on derivatives of transcendental functions. And this should be on the back side. So last section, I had you do the power rule and some indifference, and I had you write rules of differentiation at the top of the page. And I said, just put the rules down and don't put anything else on that page, because we would be adding to that the product and quotient rule. What I want you to do is turn that page over. On the back of that page, write derivatives of transcendental functions at the top. I'm going to set this page up, and then we'll fill in a few now and a few in a few classes from now after we've learned some other rules and can understand a little bit better about where these functions are from. So we have, first we're going to start with just our straight trig functions. So we're going to have d dx of sine of x equals, and this is just saying take the derivative with respect to x of sine of x. We're going to have the derivative with respect to x of cosine of x, the derivative with respect to x of tangent of x. And then additionally, we will learn about the derivative with respect to x of cosecant of x, secant of x, and obviously cotangent of x. I don't know how I got that there. All right. So the first two I'm just going to give you are sine and cosine. And the derivative of sine of x is just cosine of x. And the derivative of cosine of x is a negative sine of x. And we can see that by graphing these, and we're going to look at that next class about where these actually come from, both algebraically and graphically. But I want to do that in class with you guys. And now below that, I want you to put a heading that says natural log and exponentials. And again, we're going to set everything up on this page, but we're only going to fill in one today. So we're going to have d dx of e to the x. That's the one we're actually going to do today. And then we'll have d dx of the natural log of x. We're going to have d dx of a to the x. And then we're going to have d dx of log base a of x. And so the derivative of e to the x, there's actually a lot of fantastic memes, if any of you are in the meme world, of taking the derivative of e to the x, because the derivative of e to the x is actually e to the x. So it's itself, which is really cool. And again, in class on Wednesday next week, we'll look at why that occurs. But that's a pretty easy one to remember. The derivative is itself, which is, again, pretty cool. And then lastly, so if you keep cruising down that page, oh, all right. I'm using this program for the first time. All right, the last section is going to be inverse trig functions. And we're not going to do any of these today. Again, I just want to have these set up so that they're all on one page, so that it's an easy reference, because there's not a lot of stuff you're going to need to memorize in AP Calc, but this is one of those areas. So I want to make sure it's all set. So we're also going to learn the derivatives for the inverse trig functions. And they probably look a little funny. Actually, let's go ahead and make these X's. They probably look a little bit funny right now, but they'll make sense later on. We need to learn a little bit more calculus before we can do these. Okay, so just to kind of recap here, the only derivatives, so you have inverse trig functions we're setting up, but we're not doing anything with, are natural logs and exponentials. The only one that's we're inputting here, you should have d dx of e to the x equal to e to the x. And then for our trig functions, the derivative of sine is cosine of x, and the derivative of cosine of x is a negative sine of x.